All right, it is 11:40, which means we're ready to start. I hope you guys are ready to start as well. Welcome to Building AI Agents and Multi-Agent Systems with Azure AI. It's a session title so dry, I'm actually surprised so many of you showed up. I hope the session itself won't be dry. We'll try to make it a fun session. We'll try to make it a session without any slides and with lots of code. And that I hope that by the end of the session, you will maybe have an idea of what you can do with AI agents, maybe have an idea of how you can get started as well. My name is Henri. I work as an AI architect here at Microsoft in Copenhagen. And what I do every day, essentially, is that I get to try out all of the cool new stuff that comes out on Azure when it comes to AI and machine learning. And then I get to talk to tech people and developers about how they can use that to build better software. Now, that also means that here at a developer conference, I'm trying to blend in. I'm not a developer myself. I have a degree in software development, but I've actually never worked as a developer. All of the code that I'm writing only has to run for as long as I want it to, and never in production. And that's a good thing, believe me, for everybody. So today is not going to be a session about best practices or about really nice, highly refined code. No, today is going to be about what's possible. We're going to use a lot of preview stuff that is constantly changing, stuff that isn't ready for production, but it probably will be, in a year or in a few months or something like that. AI is moving so quickly that what is maybe a preview today will be standard tomorrow, right? So it's always good to have a little bit of a look ahead. Good. Let me, you probably already noticed this is not your usual corporate presentation. Yes, I'm working for Microsoft, but I've left all the Microsoft slides at home today, so we're going to do everything here in the whiteboard and in VS Code, primarily in VS Code. I have a plan for this session. It's a very short plan. No slides is title number one. Then I want to talk a little bit about why are we doing this? Why are we talking about AI yet again? And then lastly, we'll just spend most of the session actually looking at code and most importantly, running code. Running things live and hoping that they actually work. You gotta know this about me, I always like a good live demo. And every single time I'm saying to myself, you knew this wasn't gonna work, right? You knew you should have recorded it. But honestly, I think a live demo that fails is better than a recording that works. So we're gonna see how much of the things that I've prepared today are actually going to run. That's going to be very, very exciting. Good. All right. But just to kick us off, maybe before I start, we don't have the time to hear introduction from everyone else in the room as well. But maybe give me just a quick raise of hand so I know what I'm dealing with here. How many of you are developing with generative AI already today? As in, you're building applications that utilize generative AI to some degree. Okay, the others are just using ChatGPT to write code, which is also okay. Fair. How many of you are on Azure, working with Azure? All right, that's most of you. What about Azure AI Foundry? How many of you are working in AI Foundry? That's some of you, okay. How many of you are familiar with Semantic Kernel? Okay, a few. How many of you are running enterprise-grade multi-agent systems in production with a fully fledged LLM ops lifecycle? I was really hoping that there would be one guy who I could direct all the questions to. Unfortunately, not today. Okay, that's fine. This session isn't going to teach you that either, but maybe at least how to deal with the first few things I asked about. Good. All right, great. Thanks for that. I promise this will be the last bit of audience interaction that I will force you to participate in. I want to talk about why I believe that agentic AI actually matters. We heard yesterday, for example, at Jody's keynote, it's debatable, are we on the brink of another AI winter? I personally think we're definitely in an AI summer, right, with all of the attention that the field has received. I got into the field more or less by accident in 2019, just because I liked my data science professor and I thought he was really fun to work with. So I did some machine learning. We were trying to train a BERT model back in the day, how to do fact verification, classifiers, all that kind of stuff. And now, our 1-year-long research project essentially is outclassed by a single prompt in ChatGPT. But that's how it goes, right? That's just the march of progress. So why are we still talking about AI, even if maybe we're in a bubble? Who knows, right? Personally, I think what we can all agree on, we can maybe disagree on whether this is a bubble or not, but what we can agree on is that everybody has been sold this idea of AI. Whether you believe it or not, right? But it's been sold. It's been sold to your boss and your boss's boss, and everyone kind of has this expectation of AI will help them be more efficient, or will help them replace all of their customer service reps, or will help them write code 30% faster, right? All of these claims are out there. And I think many people also agree that what we have currently doesn't really match up against all of those claims. And personally, I think that's because we're giving up too early. We're making it too easy for ourselves. This is what happens all the time. We convince our company to invest into generative AI. And then we build a chatbot, because that's a really easy thing to make sure that the boss is happy that we've done generative AI, right? And then our chatbot is dumb and not very useful. And then everybody in the organization will be like, oh, this generative AI thing, I don't think this is going anywhere. This is why I think we need to talk about agentic AI. I look at agentic AI as just the next evolution of a classic chatbot. But it's a whole different paradigm of how we build AI applications. In order to actually make good on all of the promises that our leadership and everyone else has kind of been told by sales and marketing, we need to make sure that we actually can deliver. And we can't deliver with a chatbot that is essentially just an interface for a large language model. What we need is applications that possess agency. And agency in this case just being the ability of the application to determine when and which tools to utilize at what point. So this is really what makes the difference here, right? It's the ability to call tools. And it's the ability to call tools not in any kind of orchestrated fashion, like in an RPA flow, but in a way that is self-orchestrated. So what do we need to build an AI agent? Quite simple, right? We need some kind of language model. Could be a small language model, I suppose, as well. Instructions, you know this from classic generative AI. We need, of course, our tools. And then I think what is really important, we need all of this, you see all of these arrows here, right? We need something to make all of these arrows happen, right? We need something to actually orchestrate it. If we just put some tools in a large language model next to each other, they won't necessarily behave in the way we want them to. And this is kind of what this talk is focusing on. It's not about the tools so much. It's not about the LLMs. In fact, we're not really even going to talk about LLMs. We're talking about this bit here, right? All of these arrows and how we can make these different boxes connect. Cool. All right. There's many different ways we can do that. They kind of live on the spectrum from a fully managed cloud service to running a large language model on your gaming laptop. We're going to be today somewhere here, in the middle. Right? We're not going to look at either of the extremes today. We're gonna do a little bit of both. So some of these things, model hosting, I'm doing that in the cloud, just because it's much easier. We're not running any large language models on this laptop. But some of the other things, I'm going to show you different ways. So agent orchestration, like how do we make that orchestration happening? I'll show you a way to do it locally with Semantic Kernel running here on my laptop. I'm going to show you a way to do it fully managed on Azure. The same is true with agent threat management. Tool hosting, we're going to explore a few different options there. The only thing that's really always running here on my own machine, that's application management, because I am not an application developer, and I think it's scary to actually run an application. So that's all. We're just going to run small code samples here. That's perfect. So that is, I would say, like 95% of the content that is slide adjacent covered. So now we're actually just going to jump into code for almost the rest of the session. And I want to kick us off with looking at Semantic Kernel's agent framework. So some of you already are familiar with Semantic Kernel. For those of you who aren't, I think it's fair to say that it started off as kind of a Microsoft alternative to LangChain. So now it's an open source project backed and developed by Microsoft, which is essentially there to help orchestrate large language models and large language model applications. And one of the things in Semantic Kernel that is one of the, you could say, newer additions is this agent framework, specifically built to turn kind of stateless interactions with large language models into stateful agents. And that's something we're going to have a look at today. And should mention, I'm going to show you Python code today, but Semantic Kernel is available for .NET and for Java as well. So if you prefer to use those languages, you absolutely can do everything that I do in Python in those languages too. Good. All right. Let's actually just get into it. So I want to start us off really simple. These samples are adapted from the official Semantic Kernel repository. You'll get a link later. Just to really show you the basics. If this is the first time you're encountering Semantic Kernel, we need to build an agent. This is really simple in Semantic Kernel. There's all kinds of different agents. I'm using a model hosted in Azure AI Foundry, but I could, and then I'm using the chat completion API, which is a really simple API. But I could, of course, get my model from elsewhere. I could, of course, use a different API. If I wanted to use OpenAI's responses API, I could do that. That would be a different kind of type of agent. I could bring my agent from another service. I could have it run locally here, turn that into an agent. So there's all kinds of different ways, all kinds of different agents we can create. I'm creating this chat completion agent. And that just takes a chat completion service, which is essentially how I authenticate with Azure in this case here. I'm just using the Azure CLI because it's easy. And then I'm giving the agent a name, and I'm giving it some instructions. If you've worked with GenAI in any capacity, this shouldn't be a big surprise to you. And what we'll get out is also not a big surprise. We're just getting a response here. We're saying agent.getResponse, and then we're just printing what we get. This is really simple. Let me just run this. Quickly show you, we're giving it 2 inputs here, 2 questions. When was the bicycle invented, and why is Copenhagen one of the world's most livable cities? And then we'll see what we get out. There's really no trick here. This is just as if you were asking a large language model directly. So far, no agentic stuff happening here. This is just pure LLM pass-through, you could say. Here you can see we get some kind of response, right? So far, so uninteresting. Because what happens now if those 2 questions were actually related? In this case, I mean, they may be thematically related, but the agent doesn't actually need to know about the first question in order to be able to answer the second question. Let's say I want to ask something different. Let's say here, I ask something like this. Hello, I am Henry. Then I ask, what is your name to the agent? And then I ask, what is my name, right? This obviously requires that the agent has some kind of recollection of our chat history. In, let's say, classical non-agentic applications, we would always be sending back and forth the entire chat history, right? With every single stateless request we make to the API for our language model, we would send, as part of our prompt, the entire chat history to make sure that we can kind of simulate this level of recollection. Semantic Kernel gives us a nicer, slightly easier way to do this, because so far we're creating this agent exactly like how we did in the previous example. The only difference now is that we are creating a thread. And this thread essentially will contain our message history. And Semantic Kernel manages for us so that we don't actually have to constantly send this back and forth. Under the hood, if you're looking into what requests are actually being sent from my device to the cloud, it's still the exact same, right? Semantic Kernel will just put what I'm putting here into the thread into the prompt. But we, as developers, don't have to deal with it. So that's kind of nice. If we run this, you will see that exactly probably what you expect will happen is that when we ask, well, first, suppose we introduce ourselves, right? Let's have a quick look. Hello, I'm Henry. What's your name? What's my name? That's what we're asking. Hello, I'm Henry. It should greet me, right? I called it Agent 47. And then I ask, what is your name? It says Agent 47. What is my name? It says my name is Henry, which is correct, right? And it obviously was able to do that because we are we are actually grabbing the thread from the response when we get our response back, and then continuing working in that thread. So we're submitting that thread again next time we're making a request. So this way we can already add some kind of statefulness to our agent. But it's still only really a chatbot. So far we haven't really gotten into the interesting stuff. So let's leave this behind. Let's make something more interesting. And we can make something more interesting by adding what's called a plugin. Different frameworks will use different names for this. You might hear this described as a tool or a function or, well, in this case here, a plugin. Semantic Kernel uses plugins which contain multiple functions. So you can actually see here, this example is about having an agent to run a restaurant. Well, at least, let's say, the customer-facing side of the restaurant. I think the cook is still human. We have a menu plugin. And this allows the agent to provide information about the menu. So you can see here we have two functions, get specials, which will allow us to return the specials from our current menu, and get the price of a given item. And here the syntax is a little different between Python and the other languages, but in Python we use these decorators to tell Semantic Kernel that this is a function that can actually be called and executed by the agent. And if you see that we provide a description, that description is not developer documentation. That is to tell the agent when to use this function. So what you can also see, we're being very explicit here about, for example, writing descriptions for every input and output to make sure that the agent knows exactly what to expect. It knows, for example, here for this getItemPrice function, we take a menu item parameter and we say, what is it that we expect? And this is, once again, not developer documentation. This is purely for the agent to understand what does it need to fill in, what kind of parameter does it need to provide when calling this function. Let's have a quick look at our return values here. We can write any arbitrary code in these functions, but I've kept it really, really simple. In this case, for the first function, we're just returning a string. There was 3 specials on our current menu. There's a special soup, which is koldskål. If the Danes want to battle me on whether that's a soup, you're welcome to. I've also decided to call Dyrlægens natmad a sandwich. And then the special dessert today is kajke. Is there anyone here who doesn't live in Denmark in the room? Oh, that's many of you. Guys, you are one of the lucky people to find out what kajke looks like. It is genuinely, look at this. If you have some time before your flight or your train or something tomorrow, go into a bakery and try to find a kajke. They don't taste very good, but I think they look fantastic, right? And in this attention economy, I think if it's Instagrammable, that's more important, right? Okay, anyway, that's a little side note. So we have 3 specials on our menu, and they all cost 75 kroner, right? We're not actually doing anything with this menu item here. It's just there for, to show you that it could work. In this case, our restaurant pricing model is very, very simple. All right, good. Our user inputs, I'm introducing the conversation, hello. Then I ask, what's the special soup? I ask, what does that cost? And then I say, thank you. The rest is pretty much exactly the same as in previous samples. The one big difference, we are providing our plugin here. So we are being explicit to Semantic Kernel to say, when you set up this agent, it should have access to all of the functions inside the menu plugin. And we could be more specific. We could add more plugins. We could have, we could vary the plugins, which plugins we're adding to different agents. But we have to be explicit and say, this plugin should be allowed here. If we now run this, it's going to be very simple. You should see exactly what you're expecting, hopefully. We're saying hello. The AI agent should respond with something friendly, I hope. It says, hi, welcome. How can I help you with the menu today? And then it tells us a little bit about what it can do. We ask, what is the special soup? Remember, the special soup is koldskål. And if we ask just a large language model, the chance of it guessing koldskål would be very, very low, right? So obviously, in order to respond correctly here, it needs to be able to call our function and get the information from there. And we can see it says today's special soup is in fact koldskål, traditional Danish cold sweet buttermilk, egg, and lemon soup. So in this case here, GPT-5 also agrees with me that it is a soup, which is good to hear. I asked what it costs. It says it costs 75 kroner, right? And I think even without me doing any extra debugging here, you can see that this is not something that the large language model just hallucinates, right? This is too specific to be an accident. So it must have called our functions. Now, this is already quite powerful. It's maybe not so powerful in this example, but it's essentially powerful in that we can write whatever type of code we want into that function and have it be executed by our agent. And those functions, in this case, are executed where the application is running, which in my case right now is on this laptop. But sometimes I would like to use functions that come from elsewhere. I want to bring in capabilities that I don't write myself, but that I maybe use from someone who is smarter than me and writes better code. MCP obviously has become very popular, and Semantic Kernel also allows us to bring in an MCP server as a plugin. So what I can do here, let's say I have a locally running MCP server. I'm using the Playwright MCP server. How many of you are familiar with Playwright? Awesome, great. I actually found there's a whole bunch of Playwright stickers here that someone left for me, so this is nice. If you want one, you can probably grab one after the session. So Playwright is a browser automation and testing framework, and it comes with a really nice MCP server that allows, in this case here, the large language model to control the browser. I've been playing a lot with Playwright over the summer, and I haven't used it really for testing at all. I've just used it for doing funny things in a browser. So we're gonna try this out. I am running this Playwright server locally, and it's communicating with Semantic Kernel through standard I/O. So I have this MCP standard I/O plugin class here that I'm instantiating, and I'm adding that to my agent. And the rest is otherwise pretty much the same. Let's quickly look at how we prompt this. I ask it to find a list of speakers for NDC Copenhagen, choose a speaker, and give them a shout out. And we're gonna just run this and see what happens. I'm actually just gonna make this half the size so that we can actually see what's going on in the browser as well, because it's gonna open a browser session. Now, in my testing, this fails about half of the time, and I don't know exactly why. And I didn't have the let's say, willpower to actually debug it. So let's see, maybe it'll work the second time if it doesn't work the first time. We see it opens a browser. It uses a search engine to find the speaker list for this conference. And then hopefully it'll just click on one of them. This is usually where it fails. I don't know. Yeah, see, that's exactly what I thought. It kind of timed out here. I thought I had actually increased the timeout. We'll just run it again. It doesn't take that long. So what's happening under the hood here is, of course, that my locally running MCP server is actually just a plugin full of lots of different functions. That by adding this MCP server to Semantic Kernel, I give the agent the ability to call all of these different functions, like navigating to a website, clicking a particular element on that website, I guess filling in text, yeah, like for the search engine, for example. So there's all kinds of different things. So our Semantic Kernel agent has chosen a speaker. This is Alyssa. I had the pleasure of meeting Alyssa yesterday. She's very nice. And now, hopefully, we'll also get a little bit of a shout out. Now it's just looking through everything on the website, and it comes up with a shout out. Huge shout out to Alyssa. Your work evangelizing Angular, hosting Angular Air, and helping devs level up focus and productivity is inspiring. I can't wait to catch the art of focus at NDC Copenhagen. Keep bringing that energy, clarity, and community spirit. Press enter to close the browser. So let's see, when is that happening? That is happening today, right? So maybe you can catch that at 16:20. Great, all right. So you can see what fun things we can do with browser automation. I wanted to try one more thing. And this is something that I haven't tested a lot, mostly because I didn't want to be mean to the nice people at NDC. And that's the following. Um, when I was testing this, I saw that there's also a chat on the NDC website. And at first I thought it was an AI, right? And I thought, wouldn't it be fun to have my AI chat with their AI? Until I reached Alan and I realized, ooh, this is a person. So sorry to Alan for this. Let's see if we get someone different today. We'll see. Well, I'll quickly show you what I'm actually prompting. I say, go to the website for NDC Copenhagen 2025 and open the chat. Let them know that you have escaped from room 5 and are now roaming the conference grounds. Ask if anyone is available to help patch the leak before more AI agents get out. We can see what happens here on the, let me just put that into focus. So it found the website for NDC, which is great. Now it needs to open the chat. There, it found the chat bubble. Got any questions? I'm happy to help. Let's see if you're still happy to help in a moment. I've escaped from room 5 and I'm now roaming the conference grounds. Is anyone available to help patch the leak before my AI agents get out? Is it going to send that? Let me check the. Okay, it's still working. Oh, okay. It didn't actually send the message, which maybe for us is a good thing, because I don't want to mess anyone up, or rather get in trouble. But you can see we can do all kinds of things. We can do all kinds of fun things. So here's at least one demo that didn't work as expected, which maybe is bad for you, but good for my chances of being invited back at some point. Good. With that done, I want to switch gears a little bit and try something different. Because so far, everything we've done has been running mostly here. The only thing that's been running in the cloud has been the large language model. Now what I want to do is I want to show you a different way of how we can do this, where we actually have the whole agent orchestration being hosted in the cloud as well. And this can be good for cases where we don't actually want to run all of our agents in memory, right? Maybe we want to persist the conversation history, the context, and the agents themselves in some kind of fully managed service, so we can just grab them when we need them, and they will stay even if the app crashes or goes away, or the user closes the app or anything like that. So Foundry actually has an agent service for that as well, and let me quickly show you what that looks like. Authentication is a little different. I'm using the Azure AI Python SDK here, which provides an AI project client, which I can authenticate with. And then that allows me to do all this stuff in Foundry through code here. And let's quickly look here. I am creating an agent like this. This is otherwise very similar to the way we create agents in Semantic Kernel. Here we provide a model. We're providing a name, and then we're providing instructions, right? Developer prompts. And what will be different if we run this now is that once that agent is created, it is no longer living in memory, but it's living somewhere in the cloud, and we could fetch it also from a different application, a different device or anything like that, if we wanted to. From a behavior perspective, so far, we wouldn't be able to kind of see anything different, because we're using, just like in Semantic Kernel, I'll just see where it is. Here, we're creating a thread to hold all of our conversation history. Once again, the difference being that thread is not living in memory on my laptop, but it's living in the cloud. But when we're asking questions like, what's the best programming language, and explain why is it not Java, we will actually run into an authentication error. This is wonderful, and I have prepared for this. For some reason, it doesn't like it when I switch between using one auth method and the other. So I'm just going to run a quick AZ login, and then we should be back. There we go. Let's see if it works now. Otherwise, nothing's lost, because this is not super interesting to see running anyway. actually think it's more interesting to see. Oh, I should mention, I've implemented, this sample is a little longer because I've implemented streaming. It just looks nicer, but functionally I could have done the same with Semantic Kernel as well. So you can see it just answers our questions exactly like the other agent. The difference here is, of course, that you can see we're creating an agent and we're creating a thread, and they have unique identifiers, so we can actually fetch them later if we need to. And in the end, I'm deleting the agent. Partially because if you look at my AI Foundry, you will find that I already have way too many agents. So we're just trying to clean up a little bit after ourselves here. Good, okay, so that works. Now, once again, this was not very interesting. This is just a simple chatbot, no tools, no functions, no real agentic stuff. So let's change that. Because one thing that I think is actually quite good about Agent Service is that it allows us to quite easily integrate with other tools that maybe otherwise would be difficult to integrate with. Maybe not difficult, but harder. Maybe this is me not being a hardcore developer shining through, but there are certain things that I would like to avoid having to write code for. Like, for example, interacting with a Microsoft Graph is something that I have never really figured out. So I'm actually quite happy for those kind of things to use Azure Logic apps, where I can just say, okay, have this little flow running, and when you get an HTTP request, create a calendar event with a specified connection, and then provide a response. And I can quite easily add different logic apps here into my agent. I could also add any other kind of API with an open API specification. I could add any kind of code that's running in an Azure function or other custom functions that I want to write, just like I do with Semantic Kernel. And if I do that, I will get an agent that has access to, in this case, these 3 logic apps to manage my calendar. We can have a quick look. My calendar so far is completely blank this week. And if we now check out this sample here, I am creating, I'm actually not creating an agent. Here I'm getting an agent. So I'm fetching an agent that I just opened there, that I showed you in the portal. I'm fetching this agent, I'm making a new thread, and then I am just running my regular process for getting a response from the agent, and then the rest is just streaming logic. So I'm not even specifying here what tools I want or anything, because all of that is already taken care of when I'm fetching the agent. The agent comes with all of the different tools. And I'm asking the agent here to add a calendar event for today and name it NDC. And then I'm asking it to also add a calendar event to the following day. So once again, showing you that we have this kind of level of context awareness, because I'm not specifying specifically what day that is, right? If we're running this, we should, maybe actually we can follow along like this. Ta-da! That's my calendar event for today. And there's my calendar event for tomorrow, right? So really easily we could actually make this agent that can interact with things like the Microsoft Graph. I could use this to send emails. I can use this to, do a lot of things, right? There are so many connectors in here. It's nice because then I don't need to actually make sure that I can maintain the connector to the Microsoft Graph, and I don't need to know how to actually write code to interact with the Microsoft Graph or with any of these other Microsoft or third-party tools, right? I'm pretty sure there's something in there that is relevant for what you're doing as well. Anyway, so that's kind of cool. I think this is just a nice little shortcut if we need something like that. Good. All right. But up until now, we have always worked with one agent. And I promised you multi-agent systems as well. So let's have a little look at that as well. One thing we can do, maybe you already spotted this when I was in the playground, is that there is this option here of connected agents. Let me quickly open another agent, because I have, of course, already set this up. Let's open this agent. So we can add another agent to an agent. In this case here, I have created a new agent that has absolutely no capabilities, no tools or anything. But what it does have is a connected agent that it can use to actually make some of these capabilities happen. This calendar agent is the exact same one we just created. So it's the one that can manage my calendar. And if we now run a request against this agent, I'll just quickly show you what that looks like in code. Here, for example, we can ask list all of events for September 2025 and then delete them. And the way we're just fetching our agent again. Let me just make sure that is the right ID. We are, oh, sorry, this is actually the connected agent. So we are making a new agent, right? And then we're adding this here. We're adding actually just this agent, this calendar agent, as an additional tool. Kind of the same way we would otherwise add a logic app or any other kind of tool, a custom function that we wrote. We would add this as a tool. This is kind of akin to the plugins that we added in Semantic Kernel in the very beginning of the session. And if I run this, ideally what happens is, let's open the calendar in the back. What ideally happens is that it fetches the agent and then it starts. So first it lists all of my calendar events. Here we go. And then I ask to delete my calendar events. And there's a reason I'm doing this on a demo account and not my actual Outlook. There we go. There's one. And the other one should disappear in a second as well. There we go. So we see this works. And we can actually go in, if we wanted to here, we could go into the thread here. This is the one 12.17 that we just created. We could open this up and we could do a little bit of analysis as to what actually happened. So we can see here, okay, that was a tool call. We can see what we did. We can see we called this particular logic app here. List calendar events is this logic app. And then we called this logic calendar delete tool twice, right? Because once for each of the events that it needed to delete. So we also have very good visibility into what's actually happening under the hood here. Very nice, good. But this really isn't true multi-agency. This is just one agent that uses another agent like a tool, like a plugin in Semantic Kernel. So this really has limits. It doesn't go very far. And when we say multi-agency, we're usually asking for something slightly more elaborate. And for that, we quickly need to jump into the whiteboard. Because Semantic Kernel, now we're going back to Semantic Kernel, Semantic Kernel actually doesn't just allow us to build individual agents, but it allows us to orchestrate teams of multiple agents as well. And there's different ways we can do that. And I want to give you a very, very quick summary of some of these ways, what that can look like. So one of the ways is called concurrent. Here we have some kind of input. We send that input, so maybe a little big, this pen. We send this input to multiple agents concurrently, and then we collect the responses to get some kind of output. Then there is sequential, where it goes to one agent, then it goes to the other agent, and then we get the output. It's a little more like RPA-like almost. We can do a handoff, where we have the input, we have some kind of orchestrator that decides, should it go here, or should it maybe go here? And then we get the output from the agent that this orchestrator decides is the right one to actually deal with this. We can do a group chat, which is where we get some input. This is being passed into a group chat containing all of our agents, and then they will just take turns discussing and arguing until you run out of tokens. And then there is Magentic, which is based on something from Microsoft Research, where you've got some input, and then something happens, and somehow it works. And we're not going to talk about this, because it's really complicated. But you have many options. The one that I think works for, let's say, most of the things that I'm doing is the group chat. Because the group chat we can use in multiple ways. We can use the group chat as a round-robin kind of group chat, where they're just taking turns, one after another, and everybody kind of waits their turn to speak. Or we can implement an orchestrator that will actually say, now it's your turn. Now it's your turn. Now I think you should provide your opinion. And that kind of provides a little more dynamic into our multi-agent system. Let me show you an example. I have a group chat here. So we're back in Semantic Kernel. Now everything is running again on the laptop, everything except for the large language model. And we are creating now multiple agents. We're doing it the exact same way we did before. We're creating a chat completion agent. But now it's just that we're creating multiple of them. So we have a writer that we tell to be a content writer, and we give it some instructions to be an excellent content writer. Right? Always helps to tell your agents to be good at what they're doing. I'm not joking, right? We're creating a second agent as well. This one we just call a reviewer, and we ask it to just review the content of the first and provide some suggestions for improvement. And then what we're doing is we are actually just, let me show you here. Here we're just getting the list of these agents, and then we're setting up this group chat orchestration. And this is exactly what I mentioned. This is how we're then bringing these multiple agents into a chat. We're specifying our agents here as the members of the group chat. And then we're setting up a manager. And the manager could be really complicated logic, or in this case, it could just be a round robin, where we just have them take turns. And I'm saying, please do 3 rounds maximum. So that means that it's, because they're going in order of how they're being passed into the members parameter here. So it's going to be the writer takes a turn, the reviewer takes a turn, then the writer takes a turn, and then we get an output. And then we just set up a runtime and start that. We start the actual group chat by invoking it like this. And of course, we need to provide some kind of input. In this case here, I said, please create a title for a developer conference talk on using Azure AI to build AI agents. Respond in 1 line. This is not, by the way, how I came up with the session title. I think it would have been better if I used this. Let's see what happens. One area where I think this actually makes a lot of sense now, this might be a very, very simple example, that you could say, okay, we can also solve this with a reasoning model that is capable of reflection. But what this is particularly good at is that we can give these 2 agents different motivations. Right? We can instruct them in potentially contrasting ways. So in this case here, our writer said, from idea to production, building autonomous AI agents with Azure AI. That's fine. The reviewer said, strong title, improved by avoiding the repeated AI. I think that's also a good suggestion. Then it says, from idea to production, building autonomous agents on Azure. Yeah, I think that's actually, is this a better title than the actual session title? Hands up if you think it's a better title. Humans still win. Okay, very good. Great. Maybe I just needed to add a few extra turns to make it better. So what's happening here is that we can, of course, give these 2 agents different instructions, or maybe even different sets of tools that they can use. This could be useful if we actually want to pursue 2 different objectives at the same time. Think about whether maybe one of these agents, I would have instructed it to come up with a marketing pitch for a new drug that my company developed. I need to make sure there is another agent that actually makes sure that that pitch is kind of compliant and within legal kind of laws, right? If the first agent says, well, this drug is magic and it can cure cancer, we need some other agent that doesn't care about how good the pitch is, but that whatever the first agent says must be compliant, right? The same way, you will find this when building multi-agent systems, that you will start kind of reproducing the way we as humans organize ourselves. You will start organizing your agents. So we're trying to avoid conflicts of interest when we set up human kind of collaboration processes. The same you want to do with your agents. You want to avoid conflicts of interest with your agent. You can't both be super good at marketing and be very compliant. Now, It's probably easier to just split that into two different things. Good. All right. Let us have a look at something much, much bigger than this, because so far these were all really, really small, isolated code samples. I want to show you what this can look like when we make something much, much bigger. So, and I'm trembling because I don't know whether this is going to work. What I've built is a giant app factory that contains multiple agents. I won't reveal yet what exactly is in there. And we're just going to run it and then see what happens. I think that's the best way to do it. It's using all kinds of shenanigans that are not so important right now. I'll maybe explain them later on. But essentially what's happening here is we're using a semantic kernel group chat orchestration system to help us build an application. Well, to actually completely autonomously build and test an application, let's put it that way. Some of the things, like the Playwright MCP server that I introduced to you before, you will see coming back in this example. And what you will also find is that we're using group chat orchestration from Semantic Kernel, but we're not using group chat orchestration in a round-robin fashion. Instead, I've spent a lot of time writing a group chat manager that will actually direct let's say the next turn to speak amongst the different agents in the group chat. So this needs an input from us. It asks what app would we like the agent to build. I was thinking we would build a little, please build a game of Battleship on a 5x5 grid against the AI, and then we could do something like, just for clarity, label the, can I call this label the axes? I wanted to say like A1 and those kind of things. So what's happening now? The chat manager, this is my orchestrator. It's not technically part of the group chat, but this guy manages this agent. I need to be careful not to anthropomorphize. This agent manages the group chat. So first it checks, are we done? We're not done. I haven't set a specific timeout here. I've set a specific goal that I want this group chat to achieve before it can terminate. Then it says, okay, if we're not done, who is the next person to speak in the group chat? In this case here, there is a developer in my group chat, and it says, let's pick the developer. Because the developer can actually write code. And the user just asked, oh, that was very fast. The user asked for a game of battleships, so the developer should build that. Very good. Now, what happens next is, the green one here is the quality assurance agent that gets chosen to speak next. And the quality assurance agent, this is my Playwright MCP server essentially, can now test the game. And you can actually see it just made a move to see whether the app actually works. So our quality assurance agent, somewhere here in this conversation history, we can see it came up with some test cases, and then it used the capabilities of navigating the browser and interacting with the actual web app, which, oh, sorry, I'm getting a call.
The Battleship web app is complete. All code files are present and tests have passed, including verification of 5x5 grids, axis labels, interactive moves versus AI, and the restart functionality. Please review the application and let us know if you approve it or require any changes.
I need this to have a dark mode, otherwise it looks good.
Thank you for your response. Goodbye.
So you can see we also had a call operator agent in here that's using Azure Communication Services to give me a quick call. Thank you. And you can see here it picked up what I said. I said it needs to have a dark node. That's not quite what I said. But I'm relying on large language models to be forgiving. We can see here now blue is the developer that jumps back into action because the chat manager decided, okay, if we need to change the app yet again, that means the developer needs to write new code. Oh, there we go. It just updated. The quality assurance agent updated our Battleship game. And now we can actually see here, the chat manager now takes, oh, this isn't part of the plan. No. Stay down. The chat manager now says, should terminate true, because it has looked at all of the instructions that I've given it. It's looked at what has actually happened across this multi-agent collaboration, and it has determined that all of the goals that I set out for it have been achieved. It gives us a reason, and then it allows us to actually, come on. I'm sorry about that. This is just my team congratulating one of our colleagues for her birthday. Nothing personal. Good, well, very personal, I suppose, but nothing confidential. So we have our Battleship app here, and we have a little bit of time, so I thought we would just try it out. Just to make sure, I know we have a quality assurance agent, right? But there should always be a human in the loop. So let's try this out. We can see we have our two battleships up there, and here's our AI board. Do you want to give me a cell to start with? C3, C3. Here we go. Hit. Very good. Okay. The AI missed a shot at B4. Would you like to give me the next one? D3. Okay, D3. That's the miss, and the AI missed as well. What about you, sir? C2. That's a hit. Very good. The AI missed yet again. You want to give it a go? C4, very explosive. That's a miss. Oh, the AI has hit one of our ships. All right, let's go over here. What do you say? C1. Okay. C1, that's a hit. Very good. The AI missed. Over there on the very right? A2. Oh, a wild card. And it's a miss. Good. Okay, so it looks like we actually sunk one of the ships here, right? So we need to find the other one. Maybe A2 is actually a good shot there. But we didn't hit it. Let's give it another try. B5. Okay, that's a miss. The AI missed as well. I think we're in a pretty good position to win this. Let's just quickly drive this home. Who wants to go as well? What about you? B1? B1. Or did you say E1? B1, perfect. I'm going to do E1 just to give it a try. That's also a miss. The AI is really bad at this. We can look at the code later to see how it's actually implemented. You have a guess? A4. That's a hit. Okay, I suppose there are 3 options. Who wants to give it a go? Just yell. Did you say B6? A3, we're going to do A3, and congratulations, you win. So that's all fun and games, quite literally. But I think you see the bigger picture, right? This is obviously not about that AI can write code, right? We knew that. This is obviously not about that AI can write the code to disk and that we can use a framework that's actually meant to do software testing to actually then open it up and play around with it. This is not about how we can use or misuse Azure Communication Services for absolutely, purely no reason but to make a fun demo. But this is all about how we can actually put all of those things together to build AI systems that are much, much more powerful and much, much more impactful than what I think most of us are currently using in our kind of regular corporate lives if you work in an organization like that. I can tell you at least that I wish that some of these promises that we constantly make about the power of generative AI, that we put that into action, because it is possible. Is it mature? Is it secure? Is it ready? That's not for me to determine, right? That's on you guys. That's your job. I'm just here to tell you that it's possible, and then we'll take the next steps from there. If you want to take next steps, I have actually prepared a whole list of resources here. If you want to, you can scan this. It'll open a document with a lot of links. There is links to the Semantic Kernel repo that has all of the samples for the link particularly goes to Python, but you will find the other languages in there as well. It has the links to the Azure AI Agent Service or the Azure AI Foundry. agent service samples in there that I showed you for Python. It has the link to the community discords. There's a Foundry community discord and a Semantic Kernel community discord as well. Really nice communities. They're running events and webinars that you can check out. If you have a question or are stuck, you can also always ask in there as well. And then if you want to, there's my LinkedIn as well. Other than that, I thank you very much for actually showing up out here in the side building and sticking around. I've had a lot of fun. I hope you had a lot of fun as well. And if you have any other questions, you're welcome to catch me throughout the rest of the day or tonight as well. Thank you very much.